Hi, and welcome to Island Math. Today we're going to be discussing factors and multiples, and this will include discussions about greatest common factors and least common multiples. Firstly, let's define a factor. If a number is a factor of another, it divides that number without a remainder. Without a remainder, that's the important part. So, for instance, if we take the number 28, if I do 28 divided by 4, I get 7. Since there's no remainder in the end product, number 4 is a factor of 28. We could also write this in a different way. If we do 28 divided by 7, we'll get 4. Since the final product has no remainder, this right here, the 7, is going to also be a factor of the 28. Using this basic knowledge of factors, we can then solve some more difficult questions. We'll start now with greatest common factors, or GCF questions. So, what ends up happening is they will ask you to find, let's say, the greatest common factor of two numbers, which could be 30 and 24 in this case. Now, the way that we're going to find this is by basically breaking each number down into prime factors. So we'll factorize until we get to only prime numbers. And of course, a prime number is a number of which the only factors are 1 and itself. So let's say we have the 30 over here, factors of 30. We know 6 and 5 are factors of 30. Then 6 is not a prime number, so we'll factor that as well. And then we get 3 and 2. And so these three numbers are going to be the prime factors. Now we're also going to do the same thing for the 24. So we're going to get 6 and 4 as the first factors. We can divide that further, so then we're just going to say 2 and 2 here, and this is going to be 2 and 3. Now we're going to put the factors for each of these numbers side by side. So for the first, we got 2, 3, and 5. And for the second, we got 2, 3, 2, and 2. And what we do at this stage is we basically match up the factors between both terms. So these factors match up with each other. The 5 and the 2 don't match, and the other 2 is basically just left over. So using these numbers, we're only going to take it from 1 and we're going to multiply them. So we're doing 2 times 3. We're not going to do 2 times 3 times 2 times 3. Only 1 once they're matching. So we multiply the matching numbers and we get 6. 6 is going to be our greatest common factor between the two. So as you can see, 30 divided by 6 is equal to 5, and 24 divided by 6 is equal to 4. And using this logic, we can find the greatest common factor for just about anything that they throw at you. So for instance, if we calculate another one, let's say we're now taking the greatest common factor of two larger numbers, such as 150 and 225. We simply do the same thing. So 50 and 3. Then we can break this down further. I guess we can say 10 and 5. This is prime, this is prime. We can keep going with this. 5 and 2. And these two numbers are prime at the bottom as well. So now we're going to do the same thing for 225. Now, this is a harder one to factor just off the bat, but we can say 25 and 9. And then we can say 5 and 5, 3 and 3. So these are all of our factors for each of them. Now, just as in the last question, we line them up. 2, 3, 5, 5, 3, 3, 5, 5. And as you can see, 3, 5, and 5 are the matching ones. And so if we did that calculation, we just put 3 multiplied by 5 multiplied by 5, which is the same as 25 multiplied by 3, which is simply 75. And 75 is going to be our greatest common factor for this equation. So the greatest common factor of 150 and 225 is 75. Now moving on to multiples. A multiple is a number that can be divided by another number without a remainder. And so basically we can use the same example from before using the number 28. So let's say 28 divided by 4 is equal to 7. In this case, we're focused on the 28. The 28 is a multiple of 4 since it can be divided by that other number without a remainder. And the same thing holds true for the other scenario we had where 28 divided by 7 is equal to 4. Once again, the 28 is going to be a multiple of 7. So factors and multiples are tied into each other in a way. And using this basic definition, we will also be able to solve some more complicated least common multiple questions. Now, to start with these, they will give you some values. Let's say the LCM, least common multiple, of 7, 8, and 14. Now, this calculation can be done in your head. However, it's going to get more difficult for other questions. So you could just get lucky and guess and say, okay, well, 7 times 8 is 56. And I know that 14 multiplied by 4 is equal to 56. And so 56 is the LCM since there aren't any other numbers lower than that which have the same values for all three numbers. However, you are going to get more difficult questions such as the LCM of 36, 54, and 90. And for these, we're going to be doing something similar to the other one. So we're actually going to take the factors of this. So 36, I'm going to break it down into factors. We could get 4 and 9 here. Break it down further, we get 2, 2. Break it down further, 3, 3. Now for a question like for a number like 54, we can get 6 and 9. And this breaks down into 3 and 3. This is broken down into 3 and 2. And for 90, a much larger number, we get 10 and 9, and we can break this down further into 5, 2, 3, and 3. So now we're going to have to do something similar to the other question where we line them up. So we have 2, 2, 3, and 3. We have a 2, and we have a 3, 3, 3, and we have a 2, a 3, and a 5. Now, these questions work a bit differently. We are going to look for each unique term, and we're going to have to multiply in a specific way. So for instance, the 5 appears once, right? So that's a unique term. We're just going to put the 5 out here. Now we're going to look for where the other numbers occur most frequently. So as we can see, there are 3 3s here. So we would have to multiply this 5 by 3 times 3 times 3, which is also 3 cubed. And then we'll have to multiply the 2, which will be squared since the 2 occurs 2 times there. And so after doing this working, we'll get 5 multiplied by 3 squared, which is 3 cubed actually, which is 27. And then we're going to multiply that by 4 at the end. And so using this, we're going to find that 27 multiplied by 20 is going to give us our answer. And of course, this would just be a very long calculation, so you could put this in your calculator, 27 multiplied by 20. Did I just screw the entire recording?